Guys, we're back. Today we're looking at proving angle relationships. Okay, so dealing strictly with angles in this one. Last section we looked at the segment addition postulate. In this one we've got what's called the angle addition postulate. It says if D is in the interior of ABC, okay, interior means on the inside, if and only if ABD plus DBC equals ABC. And basically what that means, if I've got these two smaller angles here and here, if I were to add them together, they should give me the sum of that whole angle. Okay, so that's what this postulate says. And for a little example of what this might look like, we got something like this. So if I've got these two angles, down at the bottom here it says if angle 1 is 83 degrees and ABC is 147, find angle 2. Well, that basically says that this is 83. All the way around is 147. How can I find angle 2? Well, if I take the whole and I subtract the part, I should get that total part. And another way of thinking of it is just following this formula. This one plus the other, which we'll just call x, has to equal the whole thing. So you just solve this out, subtract 83 from both sides, you get 64 degrees, and there's your answer. So that's the angle addition postulate. The two smaller will add up to the whole. Now this leads us to a couple theorems. And the first theorem is what's called the supplement theorem. Supplement angles, or supplementary angles, if you've maybe heard them. So what it says is if two angles form a linear pair, meaning they make a straight line, they are supplementary angles, which means they add up to 180 degrees. So any two angles that create a straight line add up to 180 degrees. So if one was 130, the other one would have to be 50. Okay, so that's supplementary angles. Complement theorem says if two non-common sides of two adjacent angles form a right angle, then the angles are complementary. Now what that basically means is you have this side and this side. Those are non-common sides, okay, of adjacent angles, and adjacent means right next to each other. Then they have to form a right angle, and you guys know that right angles are 90 degrees. Okay, so complementary angles add up to 90, supplementary angles add up to 180. Alright, so let's use some of this to see what we get. So angles 6 and 7 form a linear pair. Keywords there are linear pair. If angle 6 equals 3x plus 32, angle 7 equals 5x plus 12, find the value of x and find both angles. Alright, so if you think of what you have, and it asks you to justify. So we have angle 6 and angle 7 are a linear pair. And basically justification there would be given. Now, linear pair means what? Well, they are supplementary, they add up to 180. So if I take angle 6, which we said was 3x plus 32, I add angle 7, which is 5x plus 12, that has to equal 180. Okay, and that's the definition of a linear pair, or the supplement theorem. Okay, and now we just solve this. So combining like terms, we end up with 8x plus 35 equals 180. And that's just substitution. Okay, we subtract 35 from both sides. So I've got 8x equals 145, and that step there would just be the subtraction and then the substitution. And then you're going to go and divide by 8. Okay, so x equals, when you take 145, grab this and make sure these numbers working out right. 145 divided by 8, that gives you the x value of 18.125. And that would be division and substitution. You know what, guys? I apologize. I wrote this down wrong. Now, the steps are going to be similar. I'm going to have to jump back up, and I'm sure some of you guys already caught this. Instead of 2, it's going to be 12. I apologize. So that's going to be 44 there. So then we subtract 44. Okay, so you got 180 minus 44. This is going to give you 8x equals 136. Then you divide by 8. And So 136 divided by 8 is 17. That works better. All right, so there's our first value. Find the x. There's our x. Then it asks you to substitute. So we take this and find the value for both angles. So 17 gets substituted in there, gets substituted in there. So we've got 3 times 17 plus 32, and that gives you 83. Now, since those two things are supplementary, you can go a couple different ways. You can substitute back into this second equation, or since you know they're supplementary, they have to add up to 180, and that would mean that this one has to be 97, and there are your two answers. All right, so that's kind of the way you're going to look at these. Find that linear pair, and that'll tell you where to go. Okay, the next things are a couple different theorems. One of them is called the congruent supplement theorem. Next one's congruent complementary theorem. Same basic idea. Supplementary, complementary, add up to 180, add up to 90. Here's what they say. The congruent supplement theorem says angles supplementary to the same angle or two congruent angles are congruent. Now here's what that means. Angle 1 is supplementary to angle 2. So these two, when you add them together, you get 180 degrees. Angle 2 is supplementary to angle 3. So if I add them up, I get 180 degrees. Well, that now means that angle 1 and angle 3 are congruent. Okay, they both have to add up to 180, and so that would make them have to be the same value. The congruent complementary, very similar. If angle 1 and angle 2 add up to 90, angle 2 and angle 3 add up to 90, then what that means is angle 1, angle 3 are congruent. Okay, so if two things are congruent, they would be, or sorry, if two things are complementary or supplementary, they would be congruent to a second angle, so long as it is complementary or supplementary as well. Now, the other type of theorem that we're going to look at is what's called the vertical angles theorem, and this may be something you guys have heard about before. Vertical angles are angles that are directly across from each other, and in this it says vertical angles are congruent. So if you think about angle 1 and angle 3, those are directly across from each other. They are congruent. Angle 4, angle 2, those are congruent. And you can use those theorems from up above to prove that, because angle 1 and angle 4 make a linear pair. Okay? These two would have to add up to 180. So would angle 3 and angle 4. Well, if they're supplementary to the same angle, that means that these two, angle 1 and angle 3, have to be congruent. Alright, so for vertical angles, any angles directly across the intersection is congruent. Alright, let's try a couple of these proofs and see what you end up with. So here we go. We've got DB bisecting angle ADC. Now, bisect means it cuts it directly in half. So if you look at your picture now, I've got my DB, which is this line here, that I'm going to draw in green. It bisects ADC. So what that means is that this angle and this angle are now congruent. So that's our given. We want to prove that angle 2 is congruent to angle 3. Alright, let's see how we can do this. Well, based on what we know, now angle 1 is congruent to angle 2. Okay, and that's the definition of a bisector. Bisector means it cuts it directly in half, so two congruent parts. Now if you look at your picture, angle 1 and angle 3 are vertical. Okay, and we know that because of the definition of vertical angles. They're directly across from each other. Okay? Now, because of what we just saw, what that means is angle 1 is congruent to angle 3. Okay? And that's the vertical angle theorem. Yes, we got that vertical angle theorem now. Now, because angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, or sorry, angle 1 is congruent to angle 2, angle 1 is congruent to angle 3, what that means is angle 2 is going to be congruent to angle 3, and that's what's called the transitive property. And since we have the transitive property, we've solved our proof and we're done. And so there's your proof. Okay, on your own, pause the video, try this proof real quick, come back and see what you got. Okay, let's check it out. So we know angle 1 and angle 4 are a linear pair. We know that angle 3 plus angle 1 is 180 degrees. And this is all just given to us. Okay, so that's given. Now since these things are a linear pair, we could say that angle 1 plus angle 4 is equal to 180 degrees. Okay, and that's the idea of supplementary angles. So, and supplementary angle theorem. Okay, now since angle 1 plus angle 3 is 180, angle 1 plus angle 4 is 180, meaning they are supplementary, we could say that angle 3 is equal to angle 4. And that's the supplementary angle theorem, or the supplementary angles are congruent to supplementary angles. Okay, and then finally, because of this congruency, we could say that angle 3 is congruent to angle 4, and that's the definition of congruency. Okay, and there you go. So that third step, let's see, what do they exactly call it? So it's the supplement congruent theorem. I'm going to go back and change it. The reason here is the supplement or congruent supplementary theorem. Congruent supplementary theorem. There are a lot of different names for these things, but if we can follow a logical step, it would work. Alright, last part of this is just a couple extra theorems dealing with right angles. Right angles follow a lot of these same properties, just making sure you understand it's with right angles. Okay, so perpendicular lines. Definition of perpendicular is they intersect to form a right angle. So what they actually do is they form 4 right angles. Okay, so if you look down at my picture, these would all 4 be right angles. Because they make a straight line, if one's 90, the other one has to be 90. Okay, second theorem there, all right angles are congruent, which makes sense because they're all equal to 90 degrees. Okay, third one, perpendicular lines form congruent adjacent angles, which makes sense. Adjacent means next to, and the two next to each other have to be 90. If two angles are congruent and supplementary, then each is a right angle. Okay, congruent means they're the same. Supplementary, they add up to 180. The only way that's possible, where they're the same and add up to 180, is if they're 90. And then the last one, if two congruent angles form a linear pair, they are right angles. Kind of the same idea. They form a linear pair means they're a straight line. They add up to 180. That's the definition of a linear pair. And then they're congruent, have to be the same. Those are right angles. Okay, so give these ones a try with this angle addition. Remember the supplementary, complementary, vertical ideas. Use your theorem and postulate sheet with definitions if you need to find these proofs. And good luck. Well, if you need some help, definitely let me know.